All right, welcome back, everybody. We're entering the third week of COMP110, and today we're going to be trying to address a new concept. We're going to introduce flow of control statements, and we're going to start with the if-then statement. So far, our programs have all been evaluated step by step by step, forward moving, one by one, line by line, as we've written our programs. But with what we're going to learn today, we're going to have some new tools in our pockets that will allow us to write code that, depending on certain conditions, will move in one direction through our program or another. And that's an if-then-else statement. We'll see there are some other kinds of control statements as well. Next, or as a part of that, because they're sort of deeply intertwined with one another, we need to understand how we work with logic in Python, specifically Boolean logic. And we'll talk about what exactly that means, but Boolean is this idea of something being true or false, and some related operators that were invented by a famous mathematician, George Boole, back in the 1800s. So we'll take a look at what is the Boole data type. So just like there's an int, float, stir, in Python, we've got a Boole data type. We'll explore some of the relational operators for how we compare two things. And we'll take a look at some of the Boolean logic operators that George Boole formalized, and, or, and not, as we are exploring this concept. By the end of today's lesson, you should be able to write programs that ask the user for input and, depending on what they say, respond in various ways. Before we get there, a few quick announcements. As most of you have seen, the scores for Quiz 0 are posted to Gradescope. And I want to say a few things about it. First, you all crushed this one. A median of 84, a mean of 82 is a great performance. If we compare this to last fall, the median on the first quiz was a 73 and the mean was a 69. So this is a significantly better improvement or performance than an improvement upon what your peers did in the fall on Quiz 0. They were pretty different quizzes. Quiz 0 in the fall was actually more like an 8-hour programming assignment where we opened it at start of class and it was due at midnight. It was a much more intense thing. We've decided to focus more on conceptual and code tracing problems this semester. This is the distribution of grades. Each bar represents how many of your peers scored in a given band. And the axis down at the bottom is the number of points. So greater than 90 or about 85 to greater than 90, 130 students scored in that band. These bands very roughly and very loosely could be thought of as A, B, C, D levels. Again, it's because a significant amount of your grade is driven by the programming assignments and the exercises and things like that, the lessons. Your final grade is going to be better than your quiz grade by and large. Regrade requests are open, but I want to mention that regrade requests are not for asking why something's wrong. You should know something was graded wrong before you submit a regrade request. If you have a question about something being wrong, come talk to us in office hours, or later today. I'll announce that tutoring is open this evening. And we're happy to work with you through any misconceptions. And if we got something wrong, please do submit a regrade request. These are going to be due by tomorrow night. And the reason we have a short window of time, typically about 48 hours following the close of an exam, in this case, it's a little bit more, or sorry, following the release of scores. This time it's a little bit beyond 48 hours, is because the best time to learn from mistakes is very soon after you had made them. And if for some reason you're looking at one of your mistakes and it's not actually a mistake, we just graded it wrong, we'll fix it. But the time to do that is now, so that it's not, end of semester and is the first time you're reviewing what went wrong on this quiz. And so that will help you improve if there were things that went awry on this specific quiz. For the select all options, they're effectively all or nothing. And that's to encourage just very carefully considering each of the options and being sure of your response. When you do submit a regrade request, you do so through the Gradescope interface. So you open your assignment on Gradescope, you select the question that is the one that you're submitting a regrade for. And if there are multiple questions, you would do one per question. Don't try and request multiple questions in the same regrade request. Each request is per question. You open the question in Gradescope, you look at it. There's a button down at the bottom of the screen, which is request regrade. You enter your rationale and we'll follow up with you. There are instructions that you can find through the link at the very bottom of the slide on Bitly, right? If you have any questions about how regrades work or how to submit one. But again, please do come talk to us in office hours. A couple of observations and reflections coming out of Quiz 0. Again, most of you did very well on this, but if you didn't, I wanted to try and offer a few tips. So first, try on quizzes not to be overly reliant on VS Code. We write these quizzes with the assumption that you could do them without VS Code, fully and without any reliance on it. If you want to check over something in VS Code, you're welcome to. Again, we can't stop you from using VS Code on a quiz. And so if you want to use it, that's fine. But we write questions, especially the diagramming questions, such that like you're not benefiting by using VS Code. In fact, you might actually be hurting yourself because you're doing double work, you're slowing yourself down. The output of our diagrams aren't really going to be what's important and what's going to be weighted most heavily when we're looking at grading the diagrams. It's going to be what came in the middle. How did we arrive at these outputs and what are the states of various things in memory? And so because these would be sort of very obvious and easy if you could just type them in, print out the result, write that down. Like that's not what this is about. This is more about understanding the mechanics of what's going on in your programs. Please do pay very close attention to the details of the concepts that we're covering. The number of concepts that we'll introduce in 110 aren't very large, but they tend to be very detailed and have certain things that you need to be concerned about. If you find yourself skimming readings or 2xing some of the videos that we post for asynchronous, that can come back to bite you. For example, there are a number of questions that came from the lesson 4 reading and the lesson 5 reading. If you got questions about some of the types wrong, subscription indexing, things like that, I would encourage going back through those. Those are some very important lessons that have a number of like detailed concepts that you really need to understand moving forward. We do expect close to 100%, if not 100%, on the lesson assignments that are on Gradescope. But this is a pretty low bar. These lessons assignments are set up effectively to just make sure you've watched the videos and have done a minimal amount of effort to understand what's going on. You're really encouraged to go beyond that, self-study by tinkering. We are going to be putting out more diagrams to practice with, things like that. So be on the lookout for that if you wanted more diagramming practice, and we'll soon have more exercises as well. Oh, sorry. Someone asked a question. Does it mean tomorrow, February 3rd? Yes. Sorry. The regrades will go through tomorrow, not today. So February 3rd. Thanks for that question. All right. Come work with us in tutoring or office hours if you can't make it. So let me talk a little bit about tutoring. Tutoring opens up tonight, and it's the place to come for conceptual questions at a pace that's very comfortable. There aren't time limits on the interactions on office hours for exercise and problem set or project help. There's sort of a 15-minute time limit. On tutoring, it's more relaxed and you can stay the whole time. We're open Monday through Thursday, 5 to 7 p.m. We weren't open yesterday because we didn't have time to announce it, but today is our first day, so we'll start at 5 to 7. And you can find the link to the Zoom to join on CourseCare. So unlike office hours where you set up an appointment, we join your Zoom. With tutoring, you'll join our Zoom. We'll have TAs there. We can break out and go into small groups as necessary. One-on-one interactions are possible in tutoring, especially when it's not very busy. But this is also an opportunity to have group experiences, to get to know some of your peers in the class, to go through problems together. And I think if you're looking for ways of connecting with your peers who are taking this class, I think it's one of the best opportunities to do so. This is the place to come for if there are questions you have following lecture today, something that didn't add up, come talk to us in tutoring. If there are exercises that for some reason your answer didn't align with what was expected and you didn't really understand my explanation for it, sometimes hearing it from a UTA will help clarify. You can go over quizzes here. In fact, this is a great place to come with specific questions about quizzes or study for upcoming quizzes. anything along these lines. But we don't offer assignment help in tutoring. Assignment help really needs to be one-on-one. And so if you come to tutoring with like questions on the next exercise, you'll get redirected to office hours. We have way more office hours availability than we do tutoring. Tutoring's 2 hours a night, 4 days a week, whereas office hours, we have about 40 hours a week of availability. There was a question that was asked, is question 13 on the quiz supposed to be worth 0 points? Depending on the version of the quiz that you had, we did weight down some questions that were deemed to either have errors or potentially to make use of something that didn't seem like it was fair. And so I think one question on each of the versions wound up being rounded down to 0. And then another one we rounded down to 1 because it was, if a quiz is taken and there are, if 30% or 20% of the class gets it right and most of the class gets it wrong, that's on us, not on you. And we'll typically nullify those questions. All right. And typically it's because they have errors in them. A few other quick announcements before we get into today's concepts. Once again, we'll have a week in review with Khaki tomorrow. She'll go over the quiz. This will be recorded once again. There'll also be some time for today's concepts. The Zoom link to join Khaki's Week in Review will be posted by tomorrow. Additionally, UTA contacts are now assigned. So this is exciting. You'll be hearing from your dedicated first line of defense contact on the team later this week. You can find who it is that you're paired with by going into Sakai under the Postum tool. So on the left-hand sidebar, you'll see announcements and then Postum, and then there'll be an email pairing, and you'll see the name and the email address of who you're assigned as a UTA. In terms of best practices, if you're looking for help, and it's something that requires seeing your screen, something that you would want to screenshot or some error, something like that, come to office hours. Trying to debug errors in code or questions about assignments and things like that over email is just really inefficient and tedious. And so if you try and email about this, we're going to bring you back to office hours. And there's a great question on office hours. Does the tutoring time overlap with office hours time? Yes, you will see that we will have hours simultaneously running for both tutoring and office hours when they're both open at the same time. We're not removing resources from office hours. If you have a question about logistics, you have a non-emergency one-off, like you need to be absent because you have a dentist appointment for whatever reason, or a specific conceptual question that's doesn't require a deep conversation, do email your assigned UTA and they'll be happy to get back to you. We try and aim for an under 24-hour response time. But if they haven't responded in over 24 hours, forward that to Khaki and I, and we'll follow up. If you have a hospitalization, death in the family, or significant emergency, do what you need to do to take care of yourself and your family first. And when you can, email Khaki and I, and we'll get it figured out from there. All right, I believe that is all of the announcements. Just a quick heads up on what to expect in the next couple of weeks. So today we're looking at if-then statements and Booleans. We'll have an exercise go out tomorrow. It'll be due on Monday at midnight or before. On Thursday, we'll have asynchronous lessons on function definitions and function calling. Functions are one of my favorite subjects in programming, so it's exciting to reach them, and I think you'll enjoy working with them as well. We'll have one more exercise go out that involves functions, and we'll give you some practice working with functions and understanding them. It won't be too intense because the turnaround's a little bit tighter, but it will be due Friday. And we're going to highly encourage you at least take one pass at it. Maybe you don't get full credit, but aim for 75% credit before the quiz. There is going to be a quiz next Thursday, and that's the second quiz of the semester. We'll have a synchronous review and practice on Tuesday, so we won't really introduce new concepts on Tuesday, the 9th. On the 11th, we'll have the second quiz of the semester. After the second quiz, the spacing between quizzes expands to more along the lines of 3 weeks. We try and make sure we get the fundamentals down and well understood in the first 4 weeks, and then we slow it down a little bit as we move forward. And then that following weekend, we've got 2 wellness days. So Monday and Tuesday, where Tuesday is a class that we would have otherwise had. We won't have any class there. There won't be anything due that weekend. This will be a nice breather after putting in a lot of hard work to get to where we are. All right. So let's go straight to a warm-up challenge question. The code listing you're going to see on this page involves a concept that you're going to learn today. So you haven't actually, it actually involves many concepts that you're going to learn today. So you haven't actually seen some of the things that we're talking about in this slide, but I'm going to give you an opportunity to see if you can imagine what this might be and think about it, because there will be times when you encounter programs that involve new concepts and you try and apply things that you already know, either about programming or generally about life, and as a first pass for reasoning. And I just want to give you 1 minute here to try and open up Polev. I'll open up the poll now and think through this. Imagine what you think the printed output would be of the following code listing if the user input was 65 for when we were asked to pick a number between 0 and 100. All right. So 89% of you correctly reasoned through this code listing, and you haven't even been taught what if-else statements are, or how this less than symbol works, or how to interpret these indentations. We're going to get to the bottom of all of that, but I want to applaud those of you who guessed or reasoned through is the better way of doing it, mentioning it. I really love you is what would be printed in this example. And to give you a brief preview of what we would expect this program, how we would expect this program to evaluate, and then we'll go talk a little bit more about the syntax specifically. Let me just walk through it very quickly. So this variable, how much, would be assigned the integer 65, right? So if we were thinking about this in a memory diagram, we would have, in our globals frame, set up a variable, how much, its value would be 65. And then when we reach this statement, this if statement gives us the ability to write programs that change their behavior based on the state of a program. And we get to write expressions like you're seeing here. This is what we would call a Boolean expression. It's either going to be true or false. Is how much the variable currently assigned a value that's less than 50, 65 less than 50, that is false, right? So since that's false, we're going to jump into what's called the else block. And again, we'll talk about the syntax in just a moment. But else says, if that first test wasn't true, go do whatever is in the else block. Well, we jump into the else block, and what do we see? Well, we see that there's another if statement here. So we're once again testing, asking the question, is how much less than 75? Well, how much was 65? Is 65 less than 75? That's true. So because that's true, we would go into what we're going to call the then block and evaluate this statement, print, I really love you. And we wouldn't print this else or go into this else block of this current if else. That would get skipped over, right? And if we tried different inputs, if we had input a number like 45, well, this would have behaved a little bit differently, right? So 45 less than 50, that's a Boolean expression, which we'll talk in way more depth about shortly. That would evaluate to true. So because that evaluates to true, if we had entered 45, I love you would have printed, and we would have skipped over everything else, because this block is only going to be evaluated if this first test were false. Similarly, and lastly, just to bring this one home, if we had entered 80, well, 80 less than 50, that's false, so we would go to the else block. 80 less than 75, that's also false, so we would go to this else block, and we would have printed, I love you so much. Based on the way this nested if then else statement is written, and we'll look at a simpler variant of this in just a second, only one of these 3 print statements will ever evaluate as this program listing is moved through. And you'll notice that the interpreter is jumping from one place, it's either jumping over and into this else block, or jumping into the then block, and then over, we would see the else block. All right, so that is a brief, intuitive introduction to if-then statements, but let's talk a little bit about control flow more broadly. So we're entering a segment where we're going to see our programs aren't always going to go line by line like we've been working with them in the past. So far, we've seen that our programs will be evaluated from top to bottom, line by line, and follow that order. Well, we're going to learn some new control flow statements, and we're going to be looking at this in the context of the programs that we write, right? So control flow is sort of a fancy word that describes what does the interpreter decide to do next? What happens next? And by default, as we've seen so far in the semester, the default is just move to the next line. And when we do this, we have a very linear flow through our programs, right? When we move to the next line, or the next statement more broadly, it's very easy to trace our programs from top to bottom. We start at the very top of our file. We see often a doc string there. We ignore it. We do whatever happens next. We do whatever happens next. One of the things that it takes some practice to get into as you're writing programs is appreciating that the computer is only really, or the interpreter is only really going to be looking at one line of code or one related block at a time, trying to evaluate that and then moving on to the next thing. But as you just saw with this if-then statement, we're soon going to be able to write programs that deviate from this default next step control flow. So when we reach various other structures in our programs, we're going to change the behavior. So until the interpreter reaches one of the following, and we're not going to have an exhaustive list here, but I want to give you a preview of where we're going and mention some of the concepts we'll see today and on Thursday, and then in the future after the quiz. So first, the one that we just looked at is a conditional if-then statement. We call this conditional because the code that is in the then block or the else block, it's only going to be evaluated depending on the condition that was tested. Right? And we'll talk a little bit more about what expressive capabilities we have for that condition. What are the things that we can test in just a moment. So on Thursday, we'll look at function calls and function definitions. So function calls and return statements. So these are two concepts that we're going to spend quite a bit of time with. We'll introduce them on Thursday. We'll spend a lot of time reviewing them the following Tuesday. And these are two some of the concepts that take more time to get comfortable with when you're learning how to program, because the interpreter is actually going to jump somewhere else entirely into what's called a function definition, do some stuff there, work through its statements, and then ultimately, when it hits a return statement, come back to where it left off. We'll get into the details of that later. The next type of control flow statement we'll look at, this will come after the quiz, are loops. Loops are for repetition. In conditional if-thens and function calls, there's sort of we're not going back to where we came from to redo something over and over and over again. But once we add loops to our repertoire, we'll be able to write code that repeats some action over many pieces of data. And this is one of the superpowers of computing, because we'll be able to write loops that operate on hundreds of thousands of pieces of data with very little code. Loops are closely related to conditionals, but we find that it's easier to get comfortable with these control flow statements if we teach if-thens first, spend a lot of time getting comfortable with that, look at function calls, and then come to loops afterwards. There are some other control flow statements that will impact the steps that the interpreter will take. So other statements, we'll see some of these, but we won't spend too much time on error processing, or exception handling is one way of calling this. We won't spend a lot of time there. We won't look at some more advanced types of functions you can write, generator functions. There are other ways that control flow can be impacted, but the three that are sort of the bread and butter, every programming language has them. You need to be comfortable with them in order to be productive as a programmer, are the first three. The last that, when you reach the end of a program, that's when the program terminates, right? So what I want to do next is talk about the syntax of if-then, and then there are a couple of great questions that have come up in chat. So the if-then statement is the first control flow statement we'll learn that has explicit syntax, meaning it's got some rules that are grammar rules that we have to follow in order to write a valid if-else statement. So let's jot some notes down here, and then we'll go and take a look at this in the context of the last question. So if-then statements. They allow us to have a fork in the road. So if we imagine some code that's happening before an if-then statement is reached, I like to use what's called a control flow diagram. So imagine, in our program, there's some code, some lines that happened. We asked for input in the example that you saw before. Imagine this is just some code that I'm saying this happened before we reached the if-then statement. In these diagrams, these control flow diagrams, we tend to use a diamond to represent a fork in the road, or a choice that needs to be made. And so this is going to be our if statement, and we're going to test something. And that test is going to have two possible evaluations, right? So this test is going to be an expression. And as we know, each expression has to evaluate down to a single value. And in this case, that value needs to either be true or false. So if it's true, and I'm going to label this arrow true. So this would only happen in the case that our test evaluated to true. Then what we're going to do is we're going to evaluate the code that is in the then block, right? And we'll look at the syntax for this in just a moment. But what we saw was if that test evaluated to false, right? So if that test was not true, we jumped to the else block. And we did what was in that statement. Now, the previous example stopped after the if then else test. There's nothing that came after it. But in most programs, there's going to be other statements that come after the if then else statement. So either way, whether we went into the then block or the else block, we're then going to finish up by running what comes after the if then statement, or evaluating what comes after it. And I'll give an example of this in just a moment. So the true path will take us in one direction into the then block, and the false path will take us into another direction. We're able to effectively write a program that has a fork in the road. And you encounter this all the time, right? When you go to a website that involves alcoholic beverages, and you say your age or your date of birth, and a calculation is done as to whether or not you're 21 or over, it will allow you in the site, or it might send you to Disney.com otherwise. There's sort of a fork in the road. And if you think about the interactions you have with a number of your applications and websites that you use, apps on your phone, this is prevalent throughout every application that you would encounter. So the syntax of the if-then statement is we have this special keyword if, right? So if is a special word in Python. You can't use it for anything else. You can't have a variable named if. It's a reserved special keyword, right? And then we're going to have a Boolean expression. And the next part of the lesson is going to talk about Boolean expressions in much more detail, right? But you've actually already seen one of these in that whenever you use less than and greater than, we had a Boolean expression. Whenever you test whether two things are equal to one another, that's going to be a Boolean expression. A Boolean expression is one that's going to result in either true or false when it's evaluated, right? And then we're going to have a colon, all right? So this colon is saying, hey, this is the end of the Boolean expression. And after this, we're going to begin our then block. So I'm actually going to just use a comment, a hash symbol, and say the then block would be here. Inside of the then block, you can write multiple statements. So we could have many print statements. We could have printed multiple messages about how much we loved the user of our program, right? I'm just going to leave this at a single comment for now. One key thing to recognize that I'm going to use purple to make a mention of this is there's a tab here. And this tab is important. Python as a programming language is what we call white space sensitive. The way you space things out matters. And when we're using statements, like especially these control flow statements, like when we're talking about if-then statements, function definitions, loops, we're going to use indentation to mean everything that's indented one level here, and as it continues to be indented by one level, is related. It's within the same block, all right? And then when we write the else statement, it's going to be important to unindent or to move back to the same level of indentation as the original if statement, all right? So this is the tab and indentation here is important. There are other types of programming languages that don't have this, that have different syntaxes and don't have this sort of feature. We then saw the else, and else doesn't have a Boolean expression. Later on, we'll look at how we can use a modified syntax to really to offer many different possible branches. So here we just see we're going in one way or another. Later, we'll learn what's called elif syntax to have many possible branches. But for now, I think it is really fundamentally important to just become comfortable with if else, right? And so the else block is only going to evaluate. So let's go ahead and make a comment for where the else block is. We'll only evaluate if that Boolean expression was false when it was tested, right? And I'm going to also extend this sort of note of importance. Your else block also has to be indented by one level, okay? So a question came up, is it limited in how many if-else statements you can add together in one chain? No, you can, anywhere you can use a statement. So we could have had an if-then in our then block. We could have had another if-then in our else block. You can deeply nest these. So if you wanted to have a lot, 64 different possible outcomes, you could write the program to do that. Later, we'll learn, actually very soon, we'll learn a technique for how to make that more manageable than what we're talking about so far. But you can have this, there's no limit to the logic beyond what you're willing to type and express. Okay, so it's worth making just a couple of conceptual notes here. So the bool expr will evaluate to either true or false. And I'm just going to shorthand eval for evaluate to true or false. Okay, when it's true, the interpreter is going to jump into the then block. It's going to go into the then block and ignore the else block. It's not going to do anything in the else block, all right? Go into then block, all right? When false, and I'm going to note go into then block and skip else. All right, when it's false, we're going to go, actually, I'm going to write skip into then, or skip past then, sorry, and go into else. Skip past the then block and go into else. Right? So this is how we achieve the fork in the road. There's a question that came up. Do you have to indent the else statements as well? So you will indent whatever is in the else block. So, you know, if you had more lines of code here, maybe if I have a print statement here, print, you know, hello, you would indent that all the same. And so we could have many print statements, as I mentioned. And by indenting these a common amount, we can sort of visualize this idea that these are related to one another. These are a related block of statements, and they all belong inside this else block. Now, as soon as, and I'm actually going to sort of try and delete this real quick, as soon as you write something else, like if I were to unindent here, print, and if I were to print after here, notice that this indentation, if I were to draw a line, you know, down, you know, where the sort of left margin of this is, if and else are at the same level of indentation, we indent by 1 to represent what's in the else block, and we unindent by 1, and this comes after. So in this case, if we were to evaluate this program, either the then block or the else block would be evaluated. And then notice, either way, we're going to go and do what comes after this if-else statement. So no matter what happened in the if-else, as soon as you unindent and continue on past that, the program will continue there. All right, great. So let me just pull up the example, and you all don't need to try and actually, let me just make sure this matches what we did in the question. You all don't need to jot this code down. We will continue on to some other notes here in just a second. But just to illustrate the indentation and to point out some things that are kind of hard to spot with VS Code, but once you see them, they really help you out. So the first is, notice how the if, else, if keywords are highlighted in a different color than, say, our variable names and our literal values. That's because they're keywords. You'll also notice these lines here. These lines are trying to show you where your levels of indentation are, right? So that's 1 level of indentation. This is 2 levels of indentation, right? So each of these lines is at least 1 level indented, and each of these is 2. And you'll notice that if we wanted to have nested conditionals or nested branching in our code, we have to continue the same pattern. So we just apply the same syntax, but 1 level of indentation deeper. So this then block, which belongs to the test of how much being less than 75, is indented by 2 levels. And this one is also for the else. Now, just to sort of illustrate a few other things that are common, if we wanted to have a similar setup in our if branch, we could have done that. So I could have said if how much is less than 25 here, print, you know, I love you a teensy bit, and else print more than teensy love, right? Just some silly little statements here, right? And that's totally fine too. And notice that same same pattern applies. If we wanted to write, you know, an additional if then else at this level, we would indent a 3rd level for the then branch and the else block of that nested conditional, right? So when I try and run this, if we want to convince ourselves that only one of these branches is going to print out, like maybe we want to print out more than teensy love. Or actually, let's test one of the other questions. One of the questions that came in was, what if we tried 75? What would happen? Well, before we do this, let's actually think about how that would evaluate. So we've got, let's imagine how much was assigned 75, right? And then we test, is 75 less than 50, right? And that's false. 75 is greater than 50. So this is the then block of this else statement, right? Therefore, we're going to skip over everything in it. We're not going to test. We don't care about anything that's in that then block. All right, we're going to jump right over it to the else because that test was false. All right, so this was the else that corresponded to the first if test. And we reach another if test, right? So if 75 is less than 75, well, 75 isn't less than 75. 75 is equal to 75, right? So this would be false. And because that's false, we skip over the it's then block. We don't look at that. And we would print, you know, I love you so much. And that's how that would work. So let's actually convince ourselves that this is, and if we wanted to try running this program, I'm just going to run Python -m lessons, and I put this in a file named challenge question 0. Again, I'm not expecting you to follow along with this, but I would encourage you to play around with this concept and create some examples of your own after today's lecture. So 75, I love you so much is printed, nothing else is printed. Now I want to mention two other things and run this demo once more. So I'm going to print before here, just to convince you that, you know, this is the first thing that happens. This is the next thing that happens. As soon as we reach this if statement, we're going to go into it. And then I'm going to print after down here, right? This is also to convince you that after this, after any one of these 4 branches run, so next time I might try and enter 35, and we would expect more than teensy love to print, right? We would expect that, and then we're going to see after comes after it. So only one of these 4 statements would wind up being printed. And actually, I'm going to add one more print statement here, just some exclamation points, just to convince you that we can have multiple statements in one of these blocks, right? So we're not limited to one print statement or one variable assignment statement or anything like that. We can keep writing as much code as we want here. I've just shown you examples that have only a single statement, right? So I'm going to run this again. I'm going to try 35, and notice that we see before was printed, and then more than teensy love, and then the exclamation points, and then after was printed, right? Looks like a question just came in. So when the if then statement is done, does the interpreter go back to the default? Great question. Yes. So as soon as we finish processing that if then, we decide to go into the then branch or the else branch. Once you're done processing those blocks, you're going to continue on in the normal mode until you see another one. Oh, great question. So what if we only have an if statement? Let me show you an example of that and one more extension of this little program we have here. So I'm going to add another if statement. So if how much, let's say, is equal to exactly, and I'll come back and talk about this equal to operator because it's a little bit funny looking, 2 equal symbols, not just 1, but you've already seen just 1 equal symbol, so you know what that means. Something different, right? So if how much is equal to 50, then what we'll do is print 50 right on the dot, right? One of the things that I didn't mention in the previous slide is you don't have to have an else branch. You do, if you're writing an if, you do have to have a then block. You can't avoid that, but you don't have to have the else keyword and an else block. That's optional. So if there's some code that you want to run only in like a certain condition, but skip over it otherwise and don't have like some alternate behavior, you can do it like this. So now if I were to try running the same program one more time, and I enter 50, notice that, you know, it says I really love you and then 50 right on the dot. But if I were to try running that same program again, oops, Python lessons.ls7, what we'll see is it skipped over, right? So I pick a number like 51 and that's okay. It says, you know, I really love you. And then we go to after, but this then block wasn't evaluated. So let's actually make a note of that as well. That's worth mentioning that the else branch is optional. All right. So there's a question of, can you have multiple Boole expressions on one line? And we will look at that in the next part of today's lesson. We need to learn how to express things like and or in order to write more complex Boolean expressions. But yes, we will be able to. And that's some great foresight. What if the input is 60? All right, let me try one more example here. And let's just trace through this one last time to imagine what happens if we entered 60 here. All right, so we've got 60 as the assigned value to how much. If 60 is less than 50, that's going to be false, right? So when that's false, we skip over the then block and we go to the corresponding else block. And now I ask, is how much less than 75? Well, how much is 60? Is 60 less than 75? That's true. So we would print, I really love you. and we would skip over the else block, right? Then, based on this extension to the program, if 60 is equal to 50, that's false, right? 60 is not equal to 50, so we wouldn't go into this. We would skip past that and go right on down to the after print statement. All right. So there's a great question, and let me try taking one more pass at explaining why we're jumping over some of these statements, right? Because there's something that's kind of not super intuitive here. If we imagine entering a number like, say, 15, and how much is 15? Well, as we think of this as humans and we look at this program, if we didn't try and follow it using the exact same rules that our interpreter will, we would see that, that's true, that's true. We don't really, that wouldn't be true. That's true. There are potentially many conditions here that are true. But remember, the computer and our interpreter are going to take our program and follow it very precisely. And when our interpreter reaches an if-then statement, this is all the then block for this outermost if, right? So this is then. This is the then block for the next if statement, right? And we only go inside of the then block if the test here is true, right? So what I mean by that is if this was 15, so if 15 is less than 50, that's false, meaning we're going to skip this if-then statements. So this if-else statements, then block, we're going to skip over that and go right down to the else, right? If that were true, remember, so if this were, oops, sorry, I was saying this backwards. So 15 less than 50 is true, right? So when that's true, we go into the then block and we skip over the else, right? 15 less than 25, that's also true. So we would go into that then block and skip over the else. Because 15 less than 50 was true, we also skip over the then, right? So let me take this one more time with 60. So how much is 60? 60 less than 50 is false, right? We don't do anything in this then block, we go to the else. 60 less than 75, that's true. So we do that then block and we skip over this else, right? One of the things that's worth spending some time considering is that any of these four blocks of these four blocks of code, given this example, only one of them will be evaluated per time this program is run, all right? We're branching in effectively one of four directions based on this program. The next exercise will give you some practice working with if-then-else statements, and we'll get a lot of practice tracing these with some examples on next Tuesday as well. All right. So the next question that I want to address is, did it print both 50 right on the dot, and it would have been, so less than 50 would have been false, and I really love you. Did it print I really love you and 50 right on the dot because both things were true? So the other thing that's worth mentioning is that this if statement is independent of this one, right? So when we write one if then else statement, it's going to have its related then block and else block. And if we have another if then statement that comes after it, notice that this test is separate from what came above it. They're considered separate things, and this would just be the next thing that the program sees as it moves on into the next part of the program. We could have also had a print statement here, right? So print, after first if, and after this one, we could have printed after second if, right? So if we think about these as parts of our program, we reach the first if else statement, we do one of those four options, one of those four branches that we just saw. Then we would go to print after first if, and then we would test is how much equal to 50. And if that's true, we would print 50 right on the dot. If it's false, we wouldn't do anything special because there's no else branch here. And then we would print after the second if. How would the conditional look in the memory diagram? That's a great question. It turns out conditionals won't impact your memory diagram. They won't show up. What will be impacted is, you could imagine if, here we had said, well, how much is assigned how much times 2. But here we had said, how much is assigned how much minus 1, something like that. You can imagine that we can actually change variables that we declared, as far as we know in our global scope, conditionally based on certain things happening. And this happens all the time when you order a pizza online, when you and you're deciding whether or not you want extra cheese or not. That would be a Boolean condition. And if so, you're going to get charged a little bit extra. Your total amount variable is going to increase, things like that. Good question. You cannot bind. So if else is a statement that doesn't evaluate to anything. And what I mean by that is, we couldn't say something like X is a bool that's assigned if X is less than, like, the only way that you can use if else, as far as we know, there's some advanced Python where you can do some clever, cute little things with this, but for our purposes, you can't do anything. The if else doesn't evaluate to any specific value. It's just a statement, and that statement is going to go in one of two directions. Now, inside of your then block or your else block, you can take some action, which would allow you to store some value in one case or another, and work in that way. All right, so I'm going to come back to some questions. I want to talk about Boolean expressions and Boolean values a little bit more specifically, so that we've got some notes on that. All right, and then we'll come back to questions after this. So when we're writing logic in our programs, we're using what's called Boolean algebra. So, oops. And Boolean algebra is a set of rules and gives us a means for thinking about true and false values. And as I mentioned at the start of lecture, the word Boolean comes from just the inventor, George Boole. But really we think about this as just true false values. In Python, what we're going to see is that the keyword bool is the data type that we will use in Python. So is Python's Boolean data type. And that's a lowercase b-o-o-l. And just like we have integers and floats and strings, bool is a data type. We can have variables that are typed as bool, and there are literals as well. So there are two literals with Boolean. So literals are either going to be true, and in Python, true is a special reserved word. So you can't name a variable true or use it in any other way. And it begins with a capital T in Python. Or false, right? So false is also a reserved special word in Python, and it begins with a capital F. Now you might be thinking, well, in most of the programs in my day-to-day life, I don't often think in terms of like true or false. I like to think in terms of on versus off, or yes versus no, when you're thinking about how you make decisions, in the applications you use or your life. And so Booleans wind up being used in a very similar way when we're writing programs. So where there are places where you might be thinking, would you respond yes to this? You would probably model that as a Boolean. Or if you were to say yes to some question the program asks you, we would think of that as true. Or if you were to have some light switch, like a toggle, is private, is your Twitter profile or Instagram profile private? That's going to be a Boolean. Dark mode, yes or no. Anywhere you have a switch of one of two possible choices, that's going to wind up being modeled as a Boolean in our programs. All right. We have a number of operators that are called relational operators. You saw some of them, but it's worth enumerating these and talking about them. So the relational operators that you need to know about include the ones that we saw, like less than, and having a hard time spelling here. The relational operators are used to compare two objects. And we looked at numbers and variables that were bound to numbers. For example, the greater than operator. And some of you noticed that, well, what if something is right on the boundary? How do you represent greater than or equal to? Or at least, right? So at least. And you'll notice that I wrote that out in kind of a funny way. You're used to seeing, a symbol like this in algebra, greater than with a bar underneath it to mean at least or greater than or equal to. Well, because that's so hard to type, most programming languages, Python included, will choose to put the greater than symbol first, followed by the equal symbol to mean the Boolean, the relational operator at least. Right? Similarly, you've got less than and at most. All right. We also saw equal to, so is equal to, and I'm going to have some more notes on this in just a moment. And not equal to, so the exclamation point followed by an equal symbol is not equal to. And all of these we like to think of as questions, right? Because we take two objects and we're comparing them. Is some number greater than some other number? And that's a question we're asking. Unlike in a mathematical context where you're maybe stating something as a condition of that's true in some sequence of formulas. In programming, we're using these to test, like, is this variable greater than some, is the age variable at least 21? So you might imagine, age greater than or equal to 21. And we're not saying that's always true for the purpose of our program. Depending on what age is, that's either going to be true or false. There's a great question about the ordering of greater than and equal to in these operators. So if you were to write this syntax, like an equal symbol and then greater, in Python, this doesn't have a specific meaning that I'm aware of. Other languages use it for special things, but the order does matter here. So if you're trying to use or express greater than or equal to, greater than comes before the equal symbol. There's not equal symbol before the greater than. You would have a syntax error. All right. The is equal to operator is very important to talk more about. So we're going to do that next with a little bit more detail. But these are the fundamental relational operators. And we'll soon take a look at, well, how do we form compound expressions? These are going to take two values. Might be two numbers, could be two strings, could be two floats. You less frequently use two Booleans, but that's possible too. And as we learn new data types, they'll often have ways of comparing with one another. Does this date come before some other date or after it? And it's a way of expressing relationships between two objects, right? So let's try taking a look at the equality operator in a little bit more detail. So the equality operator is one that is very nuanced. And as you're learning programming languages, what you'll find is that it doesn't always mean the same thing. One of the things that distinguishes programming languages from one another is what does equals actually mean? And what does it mean to compare two objects and ask if they're equal to one another, right? So the first thing to recognize is that equality, which is the double equal symbol, is not assignment, right? So assignment is an operator we've already learned. That's just the single equal symbol. And this can be kind of confusing, right? It seems like, wow, they're both using equal symbols. It can be funny to read expressions and statements that make use of both of them. These are very different from one another. Equality is testing if two things are equivalent to one another, Whereas assignment is saying, take whatever is on the right-hand side of this assignment operator and assign it to the variable or whatever it is that's on the left-hand side. All right. So as a quick example, and I actually had this as a challenge program or problem on Polev, but I think for time purposes, I just want to talk through it. Imagine we have a few variables, right? We have, say, x, that's an int variable, and it's assigned 1, and y, that's an int variable, that's assigned 2. And then we have a b, bool variable. So this is the first time we're seeing bool as a data type that we can use as a variable. And it's being assigned, the result of evaluating is x equal to y, right? Now, this is a pretty perplexing statement here, right? We're seeing lots of equal symbols. But remember, this one is assignment. And this one is equals or equality, right? And what we learned about the assignment operator is that you first have to figure out, well, what does the expression on the right-hand side evaluate to? Well, in this case, in this particular example, is x equal to y? Well, if we had just assigned 1 to x and 2 to y, this would be false, right? So this would be false. And after that equality is evaluated, false would then be assigned to b, right? So b would then take the value false and be bound to false in our stack, right? So big difference between equality and assignment, all right? So there's a question of, does the equal symbol mean it has to equal exactly? That's a great question. And that's actually what I want to talk about next. The next nuance that we're going to add to this particular set of notes is equal means equivalent in Python. All right, so I'll try and get to the bottom of this in just a moment, but equality in Python is equivalence. And that sounds like a difference without a distinction. Equivalence. So let's talk about this, the distinction, right? When we ask A equal B, we're asking, is A equivalent to B? Right? And same idea with not equal to, is A not equivalent to B, right? In Python, there's another operator that I'm going to mention now, but we're not going to use anytime soon. You might see it in online examples to try and to add some difference to this equivalence versus true equality, right? So there is the question of whether two things are exactly the same. So the is operator tests for sameness, right? And this is going to feel like a weird distinction because we don't really have a great frame of reference for how things could be equivalent, but not the same, or vice versa. So A is B, is A bound to the same thing? It's to the same object as B. All right. To understand this difference, before we actually get to the example, some of the code concepts that you would need to know in order to make this distinction, I want to use sort of a physical sample here. So in the physical world, if I asked you, in what I'm holding in my left hand and my right hand, are they equivalent to one another? You would answer, yeah, like they're both dollar bills, right? But is what I'm holding in my left hand and my right hand, are they the same object? And you would say, no, they're two different objects. So I'm not holding the same thing in one hand or in both hands. Now, if I had just a single dollar bill and I was holding it in both of my hands, and I asked you, in my left hand, my right hand, am I holding something that's equivalent? And you think, well, that's kind of a silly question to ask because of course you're holding the same thing. So, when you have something that's the same, it's always going to be equivalent. But the second test of is what I'm holding in my left hand the same object as what I'm holding in my right hand, that answer is yes in this case too. We're not yet to the point in the course where we would make this distinction in our diagrams or have a use for it. I just want to point this out now because you will see in some examples the is keyword. And in other languages such as Java, the equals operator actually means sameness, and so it's different. So you have to be very careful when you're encountering a new programming language for the first time to understand the semantics of your operators. And this is an example of where there's a difference between syntax and semantics. The same syntax, A equal to B with two equal symbols in Java versus Python, so in two different programming languages, has different semantics. And the semantics that you need to know about and care about are that we're asking when we use the equal symbols, the double equal symbol for equality, are these two things equivalent to one another, right? And when we're talking about numbers, are they the same? When we're talking about strings, do they contain the same characters in the strings? Later on, we'll look at some of the nuance for why we actually would care about this. All right. Let me just try and touch on a few other operators that are Boolean, that are actual Boolean operators, and then I'll come back to close with some questions. All right. So how do we form compound logical expressions? That's going to be with what we call Boolean operators. And there are three Boolean operators we need to know about. And the good news is you actually already have a mostly intuitive understanding of these. You've got the AND operator, you've got the OR operator, and the NOT operator, right? Actually, let me give myself a little bit more space here. Okay, so AND, OR, and NOT are our Boolean operators. So, for example, AND, maybe we have a Boolean variable that is like in-house, and we have another Boolean variable that is board. So if we're in the house board, or if we're in the house and board, or board and in the house, this would evaluate to true. And we'll talk about the exact evaluations of this in just a moment. But effectively, we're going to think of what's on the left-hand side of the AND operator as I'm going to use, let's see, I'll just use white here. So I'm going to put like sort of a conceptual name and call this bool L. So this is for the left-hand side, and bool R for the right-hand side. All right. So I'm trying to identify that to use the AND operator, we need two other Boolean expressions. These might be variables bound to Booleans. This could also be, if some variable is greater than 5 and some other variable is equal to something else. Any Boolean expressions we can use on the left-hand side and the right-hand side of the AND operator. So how does this work? Well, what happens is if and only if. So I'm going to use the mathematical weird spelling of if to distinguish that this is true only when both the bool L and bool R are true. Then, oops, let me just make this a little bit easier to read. So if both bool L and bool R are true, then AND evaluates to true. Right? And because I'm using this if and only if, you have to understand that in the opposite case, so if either L or R, what's on the left-hand side or the right-hand side are false, then this would evaluate to false. And if both are false, then this would be false. Keeping track of that, it's often helpful to use what's called a truth table. So in a truth table, it works a lot like a multiplication table, right? So I'm going to set up a truth table where I'm going to have just 2 rows and 2 columns, right? And so we imagine, okay, one variable is either going to be, or one side of this expression is either going to be true or false, and the other side of this expression is either going to be true or false. All right. So if true and true, then this will evaluate to true, but otherwise this will evaluate to false. All right. So just like a multiplication table, you drag your fingers to meet in the middle, and the only way that an AND operator evaluates to true is if both sides of it evaluated to true before that. Okay. The OR is similar, but I'm just going to use L and R here instead of writing bool L and bool R. But in the same way, both of these have to be Boolean expressions. You could imagine something like cold or rainy. And if it's cold or rainy, maybe you would want to take a jacket. But if neither of those conditions are true, then you wouldn't want to take a jacket. And so the OR operator evaluates to true if and only if either or both L and R are true. And this is going to have a different truth table, right? So this truth table will have some different outcomes than the AND operator. So true and false, true and false. So again, if either are true or if both are true, we have a true. So in this case, if one of the variables was true and the other was false, it would be true. If one of the variables was true and the other was false, it would be true. But if both are false, then we're going to have a false outcome, right? And the last of the Boolean operators is not, and this goes before some Boolean. So the not operator flips or evaluates to the opposite of its Boolean, right? So not true is going to be false and not false is going to be true. And that should hopefully be pretty familiar. So if we have an even simpler truth table with only a single variable, if it's true, then the result is going to be false. And if it's false, the result of evaluating this would be true. Let me get out of the way here. So sorry about that. All right. So if you wrote not true, this would evaluate to false. All right. So there's one other set of concepts that I need to discuss in order to complete the lesson, and then I'll stay along a little bit after class ends in order to take some of these questions that came in, right? But the idea is we've got these three operators, and these are Boolean operators that allow us to write more compound Boolean expressions. So we can use these in an if-then statement, right? So if it's cold or it's rainy, then print take a jacket. Else print wear shorts, something like that, right? So the last thing you need to know for today's lesson is how do these operators, if you have a very complex expression, which in today's lesson recap on Gradescope, there's a pretty complex expression. What is the precedence of our operators? We know when we have arithmetic operators, we have PEMDAS, parentheses, exponents, multiplication and division, subtraction and addition, right? So precedence, when we start having more complex Boolean expressions, is more nuanced, right? So the good news is it's actually pretty straightforward. First, you evaluate your PEMDAS. So you evaluate your arithmetic. Your arithmetic operators come first, right? So this is your, please excuse my dear Aunt Sally is how I learned it, right? After that, we've got our relational operators. So these were the ones that we looked at with the less than, greater than, equal to. These are all the same level of precedence, not equal to. And so because of that, you would evaluate your relational operators left to right after you've done your arithmetic, right? And next, things get a little bit more nuanced, right? So next, the not operator would be evaluated after your relational operators. So not has a higher level of precedence than and or. And has the next highest level of precedence. So and would be evaluated next in an expression. And lastly, or, all right? So on today's lesson in Gradescope, there's a complex compound Boolean expression that actually makes use of all three of these things. There's some arithmetic in it. There's some relational operators in it, not, and or. And if you simplify by first focusing on applying the arithmetic rules, and then look at, well, any relational, less than, equal to, things like that, and then not, and or, you'll be able to work through those examples. All right. So let me try and take on a few questions. I recognize that we've reached the end of lecture, but because there are some great questions that are queued up here, if you have a few minutes, I'm going to move through them. Or if you need to go on to your next class, you can come back to this video. If you're curious in what questions were being asked, it'll be online at the same URL, and just make a note of the timestamp we're currently at. All right. If question 1.2 and 1.3 are the same question, that would be an error. Just answer them as if they are the same. Answer them as if they're the same. Sorry about that. I think I meant to use the second term and the third term that would be evaluated. We'll nullify one of those questions. Sorry about that error on Gradescope. What is the difference between equivalence and sameness when you've got something like 20 and 20.0? So one of the things that I should mention is that you typically are never going to compare two different types of objects with one another. All right. So that means if you have a float and an int, you're not going to compare those two. You would need to convert one to the other first. And then your question becomes a little bit more simplified. Is 20 equal to 20? Yes. With numbers and with strings, actually, everything that's equivalent is also the same. It's not until we learn other kinds of objects a little bit later in the semester that we're going to see two objects that are equivalent but not the same. So we don't have a type yet to make use of that. Is assignment relational? Great question. Assignment is not relational. Assignment is just an operator that is a part of assignment statements. So you'll notice that like an if statement has some rules to it. An assignment statement has some special rules to it as well. And so that operator, you wouldn't consider it relational. In fact, it's very different. It's taking whatever's on the right-hand side in that expression, evaluating it, and then assigning it to whatever variable is on the left-hand side. Great question about spacing with relational operators. So if you have something like, A equal to B, it turns out Python doesn't really care about spacing here. But as humans, and as the style that we're going to encourage as best practice style in Python, you do want spaces between your operators and what we call your operands, or your left-hand side and your right-hand side. All right, so you would want a space here and a space here. Technically, they're not required by the language, but for good practice, I would encourage you to include them. All right. So there is a Gradescope lesson that has everything that we covered today is all you need to know in order to complete that. Can you do an if-then statement with strings? Yes. So we could ask the user, a fun little question, like just a real quick example. You could ask the user for their name, and if their name is equal to the string. So if we had a variable, like say name. So let's imagine name is a variable. And we ask, is it equal to Chris? We could have an if statement, right? So we could have that Boolean expression. So if name is equal to Chris, colon, print, a message that's specific to me, hi, else, we could do something else, right? And the key thing to acknowledge is that this part of my expression here, or this part of the statement, is a Boolean expression. This is going to evaluate to either true or false. And as long as what we do evaluates as true or false, we can use it in an if-then statement. So this is how we can use relational operators in order to add some conditionals to our code. So there's a question of, so same is always equivalent, but equivalent always the same? Yes. For now, try not to get too hung up on this distinction. Later on, when we learn about coming up with our own data types and our own objects, and kinds of objects. We'll have more nuance to talk about there. Are the relational operators evaluated left to right? Yes. If they're at the same level of precedence, they'll be evaluated left to right. If I'm doing, this is another good little question. So the question is, if I'm doing A and B and C. And the question is, what's the order of this? So the order of this would be as if you had parentheses around the leftmost and then the totality of it. So first, this would be evaluated, and then the last and would be. There are actually some special rules that we didn't get to today. I was hoping to, I had notes on them, but we'll come back to them later. It's a little bit more nuanced, but would allow us to be just slightly lazier. No sense in worrying about that now. There's a question of is A equal to B false? It depends on what A and B are. I don't remember the example. Let me go back to it. I don't remember which example we were looking at where we had both A and B, but if A and B were assigned, 1 and 2, and you tested whether they're equal to one another, that would be false. But if, you were doing some arithmetic and you had is A equal to B minus 1 and A was 1 and B was 2, then they would be equal to one another. Again, spend some time. And one of the ways that you can play around with some of this is in the REPL. So if I open up, just as a quick demo, a Python REPL, and I say, A is an int that's 1 and B is an int that's 2, and I ask, if I print, is A greater than B? That's false. If I print, A greater than B minus 1, or actually let me do A equal to B minus 1. So in an expression like this, the B minus 1 has to be evaluated first, right? Because that arithmetic has a higher level of precedence, and then it would be compared to A, so this would be true, right? But if I asked, is A equal to B, that would be false. Can you put an empty if statement? That's a good question. No, you have to have, actually, I'm not totally certain of this, but what I'll say is that you wouldn't have a reason to have an empty if statement. If you do, you should probably rewrite your logic. I'm pretty certain this is going to be an error though, but it's not something you would ever want to do, so I'm not actually sure. So let me just write, if how much is equal to 50, else print hello. Right? So you get a syntax error here. And the reason is, if you find yourself wanting to write something like this, you should probably rethink and flip the logic of this just slightly, right? So rather than thinking of this as if how much is equal to 50, then print hello. Well, if how much is not equal to 50 is the same, has the same logic, but allows us to avoid trying to force that into the else. We could have also written if not how much is equal to 50, right? And this would have been the same thing, but this is slightly strange. Typically you would use the not equal to in this case. But yeah, so you can't have an empty then statement. If you find yourself wanting that, you should just find a way to rewrite your logic using the Boolean operators we talked about in order to avoid it. So assignment is always evaluated last. If you've got an assignment statement, you always want to figure out what happens on the right-hand side of assignment first, and then the assignment operator will be evaluated, and that whatever the value is will be assigned to the variable. If you want to talk to a teacher or a TA about general review of questions missed on the quiz, not a single question, you can come to any resource that you can make. So you can come to tutoring tonight, you can come to office hours tomorrow, and if there's just specific little questions, feel free to email your TA. Will a variable assigned to a Boolean always evaluate to true or false? Great question. Let me give you one more example of in the REPL here. So let's imagine I'm going to have, bool A. It's a Boolean variable, and let's assign that as something kind of silly, is 1 equal to 2? And bool B, it's a Boolean variable. And let's say that's assigned 2 equal to 2, right? So I think this is the question, but just to confirm, we can have a variable that stores false, but we can also have a variable that stores true, right? So bool B would store true. So a Boolean variable can store either a true value or a false value, whatever you assign to it. As long as it's true or false, you can assign that result to a Boolean variable. All right. If I didn't get to your question today, I would encourage stopping by tutoring tonight. And I would also encourage playing around with these concepts. Start a new Python file. Doing so in your lessons directory is a great place for it. And trying to write some little programs that ask silly questions. And if something's true, respond in one way. If something's false, respond in another. The next exercise will give a lot of practice with this as well. This is a lot of content, getting both conditionals and Booleans in a single lecture, but great work for keeping up. And we'll see you with asynchronous content on Thursday, and hope to see you in tutoring this evening if you have any questions about concepts. All right, take care and have a good evening.